Hi, Math 20. Let's check out number 22 and 3-1. So our next polynomial has degree 6, but only 4 real zeros. So 4 real zeros means we're going to have x minus c1, x minus c2, x minus c3, x minus c4 for 4 real zeros. The issue here is this only gives us x to the fourth, right? X times x times x times x. So that's only x to the fourth. That's not degree 6. So what we need is x squared to bring it up to degree 6, because then we'll have x, 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 which is fourth power, and then x squared will bring it up to 6. The problem is it can't make a 0, so it has to be a quadratic that can't be factored. So we'll just say plus k. This can't factor. If it factors, then it creates more zeros. So that's why it can't factor, so that it creates no more zeros. So x squared alone would have a 0 of 0, right? So we can't do x squared because then we get a 0 of 0. So we need maybe like x squared plus 1, right? Because if you solve that, you would get x equals plus or minus a. So those aren't real zeros. Or it could be x squared plus 9, right? X squared plus 2, right? Something that doesn't factor. X squared minus 1 wouldn't work because, again, that factors. So it's something that can't factor. There's probably lots and lots of solutions. I think I'm going to pick 1 because I like the number 1. If you already did 21, right, you might remember how we had a little bit of freedom in the choice. So I chose 1. It is not the only correct answer. All right, so this part's done. Now let's go. Now we have 2 is a 0 with multiplicity of 3. So 2 will take over the first 3 for multiplicity of 3. So that step's done. X minus 2, x minus 2, x minus 2. We haven't figured out the fourth one yet, and then x squared plus 1. So x minus 2 cubed, x minus question mark, because we don't know the last 0, and then x squared plus 1. Again, right, x squared plus 1 is something that can't factor, but brings us up to that degree 6. Behaves like 2x to the 6th, so we already have the x to the 6th part down, because we did take care of degree 6. So the 2 is just going to throw a 2 out front, right? Large values means end behavior. And then this is new, f of 0 equals 8. So I think if I plug in 0, that'll help me figure out what that last 0 needs to be. So 2x minus 2 cubed, x minus, let's call it c, and then x squared plus 1. Shh. So we're going to plug in 0 to figure out what my fourth 0 is. So we have 2, 2, 2, and then our fourth real 0 for 4 real zeros. If you chose a different quadratic for this one, then you might get a different 0. So this is not the only answer, but this is a answer. So let's plug in 0, and it equals 8, because f of 0 equals 8. So we get 2, we get negative 2 cubed, negative c times 1 equals 8. Let's see what we get. So we get 2, we get negative 8, negative c, and then 1 doesn't do anything, equals 8. So what is this on this side? This would be 16c equals 8. So for this example, we divide by 16. So our c is 1/2. So that'll give me f of 0 equals 8. And we'll graph just to check. So 2, x minus 2 cubed, x minus 1/2 is my fourth real 0, and then x squared plus 1. This is a solution. So if you had chosen a different quadratic, then this 0 might have been different. So let's just check out the graph. So I graphed 2x to the 6 just so we could check out end behavior. So notice end behavior is going up in both directions. So that's one in green. And then I graphed the one we found. So we have 2x minus 2 cubed. So that's why we have a flat 0 at 2. Right? Remember, it pauses and then keeps going for a third power. X minus 1/2 is the 0 that we found. See it right there. And then x squared plus 1, notice it didn't add any more zeros. So I have 2 zeros, I have 1/2, and I have 2, but 2 shows up 3 times. And then, so that's my 4 real zeros, 2, 2, 2, and 1/2. And then we had to plug in f of 0 equals 8. And so that satisfied that final condition just by plugging in 0. So graphing is a good way to check these.